So in the last video for question number 5, we're going to try to piggyback off of the success we had in question number 4. We were able to successfully solve that equation fairly easily without having to use a whole lot of guess and check by simply using logs and that power property to do it. Now if you're looking at number 5 going, Herbert, 5's not going to work. 5 doesn't have logs. That's true. The problem in number 5, letter A, doesn't say log the same way the problem in number 4 did. But there's a very easy fix. Give it a log. And if you're like, wait, but no, it didn't just have one log, it had logs on both sides, that's totally okay. You can add your own logs to the problem to make it work. As long as you put a log on the left and the right hand side equally, you are totally allowed to do that. So the first step that's going to work for all of these questions, and I'm going to take notes as well as do the examples here. First step is to do what I call log both sides. That makes it sound like you're doing something, but in reality that just means write a log on the left and then write a log on the right. So log of 3 to the x equals log of 24. So first step, just write log on both sides. Now this problem looks exactly like number 4, and now it should be easier to solve. Second step, bring the x down. So that's the power property that we've been discussing. Bring the x down means take the x, which is currently a power, and bring it down in front of the log expression. So now we're going to have x times log 3. Now the log 24 hasn't changed yet, so I'm still just going to write equals log 24. Now the third step is to get x by itself. Now I'm going to look at x and say, well, what's x doing? Oh, it's multiplying log 3. If I need to get x by itself, I need to divide to get rid of that log 3. So the last step is to divide to get x by itself. Now this is where a calculator can really come in handy, because when I divide by log 3, divide by log 3, I'm going to get something that intuitively just doesn't make sense. I mean, the log 3 is canceling out, that makes sense, x is now by itself, but now I've got this weird fraction thing, log 24 divided by log 3, that really isn't meant to be solved in your head or anything like that. It's worth noting that in the answer space, where it says exact answer, that's actually that fraction. Log 24 over log 3 is the exact answer. And in math analysis, they'll let you write your answers like that if you don't have a calculator. If you have a calculator with a log button, then you'd be expected to actually type that in. So we would type log 24, close the parentheses, divided by log 3, close the parentheses, and we'd get an answer. The answer is expected to be a decimal, 2.89. So we would write that in where it says the approximate answer space, 2.89. Now, let's just make sure the steps made sense. Log both sides just means write log on both sides. Bring the x down in front, and then divide to get x by itself. Let's try another one just so you can see that the process is going to get really repetitive in a good way, and you can see that this is going to be a little bit easier once you know what to expect. Let's try letter B. In letter B, first step, log both sides. So log 7 to the x equals log 13. Notice log both sides just means write a log on both sides. The reason we do that is so we can bring x down. We couldn't bring x down before because the only reason the power property works is when there's a log in the problem. The original problem didn't have a log, so I couldn't use the power property. Now I have a log in the problem, now I can use it. So I'll bring the x down in front, x times log 7 equals log 13. That part's not going to change, so we just write it as equals, and log 13 stays the same. Now, third and final step, divide to get x by itself. X is currently multiplying log 7, so I'll divide log 7 to get x by itself. And I'll divide on both sides because that's how algebra works. Whatever I do on one side, I do to the other side. Log 7's cancel, x is by itself. Now we have this funky fraction, log 13 over log 7. Looks weird, but that's what we call the exact answer. So I'll copy that into the larger of the answer boxes, log 13 over log 7. Where it says approximate, that's where I'm going to type it into my calculator. So into my calculator, I'll type log 13 parentheses divided by log 7 parentheses, and I get a decimal 1.32 if I round that off. 1.32 is because of the 8 that bumps the 1 up. So 1.32 it shall be. Now it's worth noting that if you have access to the answer key, you can obviously just check your answers as you go. But if you don't, here's another way you can check your answers. Plug it in to the original problem. 7 to the power of 1.32 gives us 13.04, which is really close to the original 13. The only reason it's not perfect is because I rounded. If I hadn't rounded, and I did 7 to the power of the actual answer I got, 1.318123223, I would have gotten exactly 13. Now, it's not worth it to type all those digits in, but it is worth noting that's why our answer works. Let's look at another one, especially for those of us who feel like we're starting to get the hang of it. This is definitely the goal, is that you can start to say to yourself, hey, wait a minute, same steps every time, I got this. So I'll keep kind of moving my steps over so I can see them each time I do a new question. First step, log both sides. Log 1.05 to the x equals log 2. Now that I have a log, I can bring the x down in front. That's the whole point of putting the log in the problem. So I have x times log 1.05 equals log 2. And now, to get x by itself, I will divide. Divide by log 1.05 on both sides. The left side is where it cancels, that's what we wanted. The right side gives us the fraction. The fraction can immediately be copied into my answer space, log 2 over log of 1.05. And then it can be typed as is into the calculator so I can get my decimal answer. Log 2 parentheses divided by log 1.05 parentheses 14.21. Again, if you want to verify, you can totally plug this in just to check. If I plug that into the original problem, 1.05 to the power of 14 point, and I'll just type it all in to be safe, 20669908. Yep, gave me 2, just like the original problem said. Last one, just to make sure, and if you're starting to go, wait a minute, Herbert, I'm seeing a pattern here. I think I could do this without doing all the steps. That's great. If you can, go for it. Totally up to you. And if you feel like you can't, no big deal. Here are the steps one more time. First step, log both sides. So log 14 to the x equals log of 9. Second step, bring the x down. There it is as a power, bring it down to the front. X times log 14 equals log 9. Last step, get x by itself by dividing on both sides. Divide by log 14, divide by log 14. Those cancel, so you get x by itself, and now you have your fraction, log 9 over log 14. And you can type it into your calculator. Log 9 divided by log 14 is 0.83. Now, that, in a nutshell, is why we use the power property. It's to be able to solve problems like that quickly without having to guess and check ugly decimal numbers. If you have time to try 6 and 7, that's great, but if you don't, it's not essential. This is basically just a quick introduction into the types of problems for which the power property will come in handy. Again, a lot of this is just preparation for math analysis. So if you get it, that's awesome. If you don't stress. The whole point is just exposure, and now that you've been exposed to the power property, it should make things easier so that when you get to math analysis and start to solve some real problems with logs, you'll be able to say to yourself, well, yeah, I have seen that thing before, and not just have to start from scratch.